those are known as resonant frequencies, and so that's because the frequency sort of resonates with this certain material that makes up this platonic wave. And so the areas where the sand stops, those are called nodes. Because, like, if you look at this waves graph, nodes are points where the frequency is equal to 0. And so at those places, the sand sort of settles into and doesn't move at all.
And bonding plates are also used for many other things in daily life, like in the car. As you can see over here, like you can make high fancy patterns as like a spider web is actually known as like a bonding plate pattern. And tuning violins and guitars, as guitar makers and violin makers, if they were to like spread some sand and maybe like strum or like blow the violin, then the sand would fall from some places and stick on some places due to like the nodes.
And these are some pictures with different frequencies. But the reason we don't have these patterns is because our generator, when it goes up to
332. Oh, okay, got
which
it,
is
got
actually
it.
pretty low, because the more expensive ones go up to like 10,000, and they're like cost like
As you
$1,000.
can see in like the video,
But these are some different
like the
frequencies.
lowest frequency, it makes this patterns, and like 345 makes this pattern, but we only have like
Okay, got it, got it.
so ours is relatively
Cool.
relatively low. And to concluding our presentation, this is like usually I've set up during the meetings. Like you have like sand and then salt shaker, like our body plate setup, the electrical inverters, and the operation box. And higher frequencies get more patterns. Like as you can see in the research, if we were to go like higher,
Oh, cool.
10,000, even more. And
This is a cool one, which is 6051, which has many different designs.
Yeah, okay.
thank you.
Okay, says.
Take all of that and compact it small. Get this little metal piece on top. And then if you do some gears, you can attach some wheels. And then you get yourself a little thing that can spin.
Actually, you should hear this afterwards. Yeah.
You can just attach it all together.
It's right there.
add an
Loop
Arduino,
around.
get some code. You got yourself
Yeah,
a little art.
just go around. Yeah. Sure, control them. Sure. Off road. What's the what is the number? What is the number?
That's voltage in the back.
Oh, nice. Wow.
Oh.
So is he controlling the voltage? What's he controlling?
He's controlling the direction.
Just the direction.
So, yeah.
But what's stopping the forward and what's stopping the movement? The voltage.
So basically how the whole thing works is
It's really cool. So I haven't go to my
yeah.
Anyways, really awesome.
So basically, this IR sensor gets infrared waves from this remote, and it takes those waves and it tells it, okay, if this person pressed the side arrow, or that side arrow, it tells it, okay, then you have to move these left wheels forward and these right wheels backward. And when you do that, they take it to the L290N motor driver, which is like a muscle, and that turns the wheels according to the Arduino. So that's it. And then yeah.
What did you? Where did you get the frame?
The frame, yeah, I got it on Amazon. Everything on Amazon, yeah.
And you assembled it.
Yeah. Huh? So basically, did I tell you how a DC motor works?
Nope, you can restart it. Yeah.
So the Lorentz law of physics and force states that any current carrying conductor placed in a magnetic field will experience movement. So essentially, to a DC motor, there are two parts: the magnetic field and a current carrying conductor. So any DC motor will have the magnetic field that comes from this magnet, and the current conductor, which is copper wires. So according to Lorentz force law, this should spin. So if you take that, you can build it completely differently. You have a current carrying conductor, and the magnet magnetic field which comes from these two magnets. And if it's on, it should spin too. You got yourself another DC motor. So after learning all this, I wanted to know two things. Was voltage better for increasing DC motor speed, or was magnet size better for increasing DC motor speed? So I ran some experiments, and I instead of connecting the DC motor to the battery, I connected it to this, and I changed the voltage and recorded the results. And I saw that the high voltage, the higher the DC motor speed. In my second experiment, I instead of increasing the voltage, I increased the magnet size. But I got results that didn't really match to what I expected. So I said that the experiment was failed and I didn't record it properly. So after searching for other ways to record it, instead of using that DC motor, I used this DC motor and I used a tachometer to record it. And I saw that the greater the magnet size, the faster it spins. So I can
Oh.
have it spinning right here.
Oh, cool.
So I have a magnet, it should speed up. Speeds up.
Oh,
Attach
cool.
the opposite polarity, which makes the magnet slow,
Magnet
slows
make
down.
you speak up. Okay. Cool.
I recorded the results, and after seeing everything, I said that voltage is better for increasing DC motor speed than magnet size.
Oh, very
So
cool.
then if you take all of that and attach it to, did I already show you this part?
Oh, you have already
So if
shown
you
me.
take the DC motors,
That's okay.
yeah, if you take the DC motors and you attach it to an Arduino and add an infrared sensor that you can control with the remote, it can work as a car. It's like the remote will go, you press up on the remote, the infrared sensor will take that signal and says, okay, the remote said go up. It doesn't know what that means. It takes the Arduino. The Arduino said, okay, up means all four wheels go forward. So it sends that to the motor board, up to 90 degrees forward.
Magnet.
The muscle is the magnet.
我赶快要摸。
剩下你自己慢慢看，妈妈在旁边等，
然
好不好？
后，
你自己慢慢看，好多，还好几个。
然后，那你要。
如果有可以的话，还可以拿绿色给我包。
没有。
You're doing great. Very good.
Thank you so much. Our experiment is about how Skittles dissolve differently in pH solutions. These are 3 different pH solutions. This one's vinegar. Vinegar is acidic. This one's neutral, and this one is alkaline. It has baking soda in it. And if you put Skittles in here, as you can see over here, they dissolve completely differently because of how dense each object is. Also, do you want a Skittle?
Okay.
Here. Some of it, yeah. Just take some. Okay. pH thing. You dip it until you put it out. That. Now I don't know where to put it. Just put it here, you know? Yeah. Dip it quickly and put it back out. Yeah, and put it there.
Welcome to the 2026 first ever annual Auto Stemfair. Thank you for attending. This fair was planned by Shea Al-Khali and Ahmed
So this is about hot ice. It's a type of it's actually just sodium acetate but in crystallized form, and it's commonly found in reusable hand warmers. This can be created in with vinegar and baking soda, or you can also use sodium acetate in a 24 to 1 ratio. So you would make this by boiling vinegar and baking soda or sodium acetate into a clear liquid, and then pour this out into a petri dish. Once it's cold to room temperature, you can add a sea crystal and then wait for it to crystallize. Do you have any questions?
What is the point of
So we like eat and eat together. I've always had a fascination towards the world displays,
What?
especially boxes. And this is like a manifestation of that, you know, passion.
What was your original idea? Did you think I want to
The original idea was actually a heart rate sensor. This was supposed to be connected into this hub, and then it would display the heart rate sensor and smart animation. We were also supposed to have a buzzer that would make a noise, but again we had some technical difficulties and the cards weren't able to connect as a play. There were some communication.
I'm his mom.
You know, I've been there. Don't worry. You know, I'll tell you, procrastination makes best engineers. Basically,
Because you automate
So many marine animals, like turtles and like they're just facing endangerment because when you're on a ship, it's not going to say much to you. It's really fatal to animals. It's going to pull their skin until it's really hard for them to swim, and then they're going to eventually kill. So I made a little experiment to see, and even though like we don't use canola oil or olive oil to run a ship, I mean like we just decided to see it, and even here in the doctors office, the motor oil is it's actually really thick versus like they're just like taking space, but this is actually really thick. And oil spreads with water because it's hydrophobic, so it doesn't mix. It's less dense, and it possesses a lower surface tension because so the water has a higher density, so it's gonna cause that's gonna cause it to stay on the surface, and it will never ever mix with water. This is much more like this. This is the law of the life to actually get back.
But like actual erasable pens, they only come back with a
Interesting. I didn't know that. Wow. Nice work, my friends. Job. I wish I could spend, like, I feel like all these experiments, I could spend the whole night just talking to you about your experiments, but I want to make sure I get to see everybody do this. So, thank you very much.
So this is thermochromic ink. Basically, thermochromic means that when you apply heat, it goes color and disappears. So for ours, when you apply heat to any one of these paintings using the hand warmer, it actually becomes transparent. So you can try it too. Just take a hand warmer and then push it against the painting.
So then even in the picture, you can see the other oils and how they make it. It's so hard to take pictures of those spaces. Like these ones here are just like
And then it becomes transparent.
you can actually see the thickness, even if it's like
At some point it'll come back because this is really sensitive. So it doesn't take a lot of like cold to come back. But in real life, the thermochromic technique does help. It does work. This here is actually rated an erasable pen, which uses thermochromic ink. When we slow dried our experiment, this actually came out, and we had to freeze it to get it back.
Can you use one of your $1,000 bucks? Hi. Would you like to see our contract?
Sure, sure.
Okay, so our project is about space debris. Yeah. So we have so this is about solar effects, types of distributions, and growth/statistics.
So you can read our like trifold, and you can ask us if you have any questions.
And the second part of our project is
We have a few visual models like here if you'd like.
Yeah, and just like for general idea, space debris is like trash in space. So when the spacecraft is launched, like rockets and satellites, when they're launched, they just stay there, right? Like there's thousands of spacecraft, like satellites roaming around. So like we need to make sure that we get rid of that before it becomes too much, that we can't even fly like planes.
So if you'd like, we can show a demonstration.
Sure. So this is like basically this is a company that's working to stop this problem, and this is like an aerial view of space debris. So you see these red bits? So that's the debris, and then these green things are actually like the satellites and the rockets and all that. So right now they're monitoring over 25,000 objects. And these red areas are the areas with the most trash, right? The most debris. So like these areas are like most impacted. And the problem with this is that like eventually like it'll be really hard for space exploration, right? Because there'll be so much debris that like it's so hard to live like to fly an aircraft.
Yeah. And listeners, so imagine this is space debris. So this is just a non-operational spacecraft going around. But here's the thing: space debris moves at 750,000 miles an hour.
Hey guys, I have another announcement. We have a lot of projects on that side too. There's like the Wi-Fi wireless communication.
75,000 kilometers an hour. So it happened from crashing. And this actually did happen to the crash when was found on their house. So like I know thank you for your help so here's some candy and a hat.
So like if you want to thank you, this is like an aerial.
Thanks.